Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2019. This question was from the topic of dimensions and this was based on multiple choice correct question. The question was simple, but in my opinion this type of question came for the first time from the topic of dimensions. So those students who might not have seen these type of questions in dimensions might have faced slightly panicked, but overall the question was simple. So in this case, in this question, it is said that there's a system of unit which has been defined in which the dimension of mass and that of angular momentum is m0, t0, l0. That means they are dimensionless. So we have to find the and length has usual dimension of capital L. So we have to find that dimension of force, power, energy, and linear momentum in terms of L, right? So first we can say that the dimension of mass, which in our usual notation is capital M in the system that we study, would have become small m0. L remains the same, so I'll be using the same L, L0 and T0. So I'm taking the small lettered symbols for the new system and capital lettered symbols for the old system, right? Angular momentum in our system is mass into mvr. Basically I'm using, if we use the formula mvr, so m is mass, v is velocity, which is lt inverse, r is distance again, so that will become squared, is again has become dimensionless, so it has become m0, l0 and t0. Now if you simplify it slightly, so you'll be able to see that capital M anyway has become 0. So this capital M can be ignored because it has become m0, l0, t0. So this quantity becomes L square into T inverse, which is M0, L0, T0. So basically we have to keep in mind this relation. Now let's go to the question. If you see the dimension of force, if we see dimension of force is nothing but mass into acceleration. So mass is m and acceleration is meter per second square. So that is LT minus 2. Mass has become dimensionless, so m can be replaced by this. So basically you can simply forget capital M. Now LT minus 2, right? So what I'm going to do, let's say if we square it. So if you square this equation, so it will become L to the power 4. Let me square it. Okay. So if we square it, I'm writing here. So it will become L to the power 4 into T to the power minus 2. This anyway will become M0, L0, T0, right? I have squared this. Now it is easy to see M has gone. So if you see from here, L to the power minus 2 will become L to the power minus 3. If you take L cube this side, so this is exactly what we are going to get. So can we say that this L to the power minus 2 is actually L to the power minus 3? So hence force ka dimension is this. So option A is right. Okay. If we talk about power, power is nothing but force into velocity. So power is nothing but force into velocity. So I'm using small p for power. Okay. So force is L to the power minus 3 into velocity. Velocity is LT inverse, right? So we can see from here that this becomes L to the power minus 2 into T inverse, right? Now if you again see from here, uh, if you if you see this equation, okay, so let me do it on the next slide. Okay, L square T inverse is dimensionless. L square T inverse is dimensionless. M0, L0, T0, correct? And we have to find the value of L to the power minus 2. So what I'm going to do, I'm going to multiply by L to the power minus 4 and L to the power plus 4. So this can be done as L to the power 4, L to the power minus 2 T inverse, right? Which is dimensionless. So we can see from here, this becomes L to the power minus 4, right? So basically we can see that this quantity can be written as L to the power minus 4. Okay, so this option was wrong. Dimension of energy, if you want to see dimension of energy, energy is half mv square, so half doesn't have any dimension. So we can say mv square. Now m is mass, v is L square t to the power minus 2. That means v square is L to the power L square t to the power minus 2. Mass again is dimensionless, so we can forget that. L square t to the power minus 2 can be again seen from this. If you take L square this side, so we will be left with L square to the power minus 2. So if L square goes this side, it will become L to the power minus 2. Make sense? And hence energy has a dimension of L to the power minus 2, which is what was written in the option. Linear momentum. If you take the symbol of linear momentum as capital P, so it is mass into velocity. Mass anyway is dimensionless, so we are forgetting that. LT inverse. Again, LT inverse can be found from this equation. If you take L this side, so you will be left with LT inverse. L, if it goes this side, it will become L to the power minus 1. So we can say that this can be written as L to the power minus 1. I hope you would have understood. So option D was also right. So again, as I said, this was a simple question, but this was novel in the sense because not many times in the previous years this type of question was asked from dimensions. So in that sense, it was slightly novel, but overall the question was easy. I hope you would have understood the solution. Thank you.